Hello everyone, Jain to all. Welcome in Digital School of Ajay Kumar Garg Engineering College, Ghaziabad. In this video lecture, I am going to discuss about the basic concepts of data structure. This is the outline. Introduction to data structure, types of data structure, linear data structure, types of linear data structures, non-linear data structure, and types of non-linear data structure. First, we are going to discuss about what is meant by a data structure. A data structure is the mathematical or logical collection of data which is organized inside the main memory. Data structure is a particular way of storing or organizing data in memory of computers so that these data can easily be retrieved and efficiently utilized in the future when required. The data structure is the basic concepts which is used to maintain or store the data inside the main memory. And how the data is efficiently organized or how the data is efficiently stored inside a main memory, that concept is called data structure. Data structure is basically used to organize or manipulate data inside the main memory. The next point is types of data structure. The data structure is divided into two parts, mainly two parts. The first one is linear data structure and second one is non-linear data structure. In case of linear data structure, data is stored in a contiguous memory location. Means if this is a memory space and we want to store the data by using a linear data structure, so we first store at this place, then this, then this, then this, and all data is stored at a single level, then the concept is called a linear data structure. In case of linear data structure, there is no level of data, all the data is stored at a single level. The second one is non-linear data structure. In case of non-linear data structure, the data are stored at, or element are stored are at different level of the memory space. That means one data is at this place and second data is at this place. Such type of concept is implemented in case of non-linear data structure. Linear data structure are different types like stack, linked list, queue, array. Such type of data is called linear data structure, and non-linear data structure have covered graph and tree, in which each data is stored at a different level. So the data structure is called linear data structure. This is a basic chart in which we show the basic classification of data structure. Firstly, the data structure divided into two parts. The first one is primitive data structure and second one is non-primitive data structure. Primitive data structure are those data structure which is predefined in your compiler, where the non-primitive data structure is a data structure which is constructed by using a primitive data structure. That means a data structure which is constructed or implemented by using primitive data structure is called non-primitive data structure. The primitive data structure are integer, float, character, boolean. Such type of data structure is already defined in your compiler, so that this type of data structure is called a primitive data structure. A second one is a non-primitive data structure. A non-primitive data structure is classified into two parts, linear data structure as well as non-linear data structure. Non-primitive data structure is defined or categorized by using a primitive data type. Primitive data type is also called derived data structure, in which we have to use integer, float, character or boolean type of data structure. In case of linear data structure, the data structure which are stored at a single level, there is no classification of level, then the data structure is called linear data structure. And in case of non-linear data structure, the data is stored at different level of the memory, so the data structure is called non-linear data structure. Linear data structure is classified into 4 categories. The first one is array, second one is linked list, third one is stack, and fourth one is queue. This is the basic types of linear data structure. And non-linear data structure is also classified into 2 categories. The first one is tree and second one is graph, in which we have discussed about the different types of operations as well as the implementation technique of these types of data structure. Now, this is the first type of linear data structure, and the data structure is called array. This is the basic types of data structure which is implemented inside a memory by using a linear concepts. Linears means if a data is stored as a contiguous memory location, then the data structure is called linear data structure. In case of array, the elements are stored in a contiguous memory location. Here, if we want to define what is mean by array, that the array is the collection of similar type of data structure. That means if you create an array of size 50 and you declare the types of array is int, then we have to store integer type value in case of these types. And if we declare character A, then we have to store in this array only character value. So such type of data structure is used to implement a single type of data structure. If we want to store 100 value of integer type or 100 value of character type or 100 value of float type, then we have to create int A for 50, character A for 50 or float A for 100, etc. So the array is a data structure where value or items are placed in a linear order, which means the memory assigned to each item is contiguous. Contiguous means the places are divided internally but not separated. That is the one by one. First element is stored on the first position, second one, second, third one, third place. Then such type of memory is called contiguous memory allocation. The data type of an array is the same for all the elements presented in it. This is the basic concept which is discussed. If we create int A, that means we have to store 50 value of integer type. That means if we create an integer data type or integer array, then we have to store only integer value. Or if we create a float data type or character data type, then we have to store only float or character value only on that data variable. The data structure which is classified into 2 categories. That means array is classified into 2 categories. The first one is one-dimensional array and second one is multi-dimensional array. One-dimensional array is called 1D or linear array, and multi-dimensional array is also classified into different categories. The 2D dimensional array, 3D dimensional array, 4-dimensional array or m-dimensional array, etc. One-dimensional array means if an array having only row or column, then the data structure is called one-dimensional array. Like this, if we use one subscript to declare the data, then we have to write int a 10. This is a linear data structure because here we have to use only one subscript to denote the structure or denote the variable. So such type of data structure is called a linear data structure. Here, if you want to show how the data is stored inside a memory or how this such type of data created inside a memory, we have to write like this: a memory location. The name of the memory location is A and the places is 0, 1, 2, 3, 4 and etc. up to 10. Here we have to store value for each element. So such type of data structure is called one-dimensional array. And the second one is multi-dimensional array. In case of multi-dimensional array, for declaration or creating a data type, we have to use more than one subscript to denote the data or denote the element. For example, if we want to write like this, int a 10 and second bracket content 20, that means this is a matrix of the dimension 10 cross 20, and this is the two-dimensional array, because here we have to use only two subscript to represent or declare the data. If we use like this A, I, J and K, here three subscripts are used, so this data structure is called three-dimensional data structure, because we have to using three subscript to declare the data. So that by using such type of concepts, we have to create different types of data structure, which may be 1D, which may be 2D, which may be 3D. And by using subscript, we have to classify this data structure is 1D, 2D and 3D. If the data structure is 1D, then one subscript is used to declare the data. If the data structure is 2D, then two subscript used to represent the data. If the data structure is 3D, then we have to use three subscript to declare the given data. This is a representation of diagrammatical representation of data structure. Here the first one is one-dimensional array. This is the memory location where we have to create a one-dimensional array, and the default location start with each indexing start with 0, 1, 2, 3, 4, 5, 6. If we want to access from 1, 2, 3 or 4, we can access the data, but in case of default value, the indexing of array start with 0. This is a diagram of two-dimensional array. Two-dimensional array means there is a row and number of columns. Here number of rows is 3 and here the number of column is 4. So we can write like this, int a 3, and this is the number of column. By using such concepts, we have to create multi-dimensional array in a different form. This is the 2D. If we want to create third dimensional or 3D array, so we have to write int a3, 4 and 5. That means this is the size of the block, this is the number of rows, and this is the number of column. That means we have to create a matrix of 4 cross 5 of each of block 3. That means each page contain 4 cross 5 matrix and the number of pages are 3. This is the main concept which is used to create a data structure or a data variable to store the given value. The mathematical application of two-dimensional array is matrices or table. In business application, we can say matrices as a table, and in mathematics, we say the two-dimensional array as a matrices. The second one is linked list. This is also a basic type of data structure in which it is the collection of nodes and each node having multiple parts. If we have talked about singly linked list, then the singly list is a collection of node and each node is divided into two parts. The first part contain information and second part contain the address of next node. Such type of data structure is called singly linked list. So that the linked list is divided into different parts, singly linked list, doubly linked list. In case of doubly linked list, each node is divided into three parts. The first part contain the address of previous node, the middle part contain information, and the third part contain the address of next node. And such type of collection of node is called doubly linked list. So we can define linked list easily. A linked list is the collection of nodes and each node is divided into different parts. Here we have to give the definition. A linked list is a data structure used to store a collection of elements where each element, that is called nodes. Here in case of linked list, the data is called data is represented as a node, contains its value and a reference to the next node in the sequence. Unlike the structure array, the user can dynamically adjust the size of linked list as per the requirement. This is the advantage of linked list over array. In case of array, the searching, deletion are take two time, but in case of linked list, the operation like searching and deletion are take minimum time to search a given element or delete a given element. So that in case of larger data or complex data, we have to use linked list. And this is also support the concepts of dynamic programming. In case of array, if we have to initialize value of array at initial, then if we want to change the size of array, so we have to change the value of inside the code. But in case of linked list, there is no need to change the code. We have to create number of nodes according to our needs and initialize the value according to the given data. Now, this is the structure of linked list. Here we have four nodes. The first part contain information, that is A, here B, here C, and here is D. And the next part is contain the address of next node. This is the pointer field which contain the address of next node. The last node contain the null value. That means that indicate that the value of next to this node is, in case of null, we have to write like this, \0 for assigning the null. The first part is called data part and second part is called next pointer part. And here we have to create a special node. The special node is called head. Head is a pointer type variable which contains the address of first node in the list. Now, the next data structure is stack. A stack is a linear data structure that follow the LIFO, last in first out principle, that allow the operation like insertion and deletion from one end. That end is called top. If we implement or restrict the insertion and deletion operation on a given data structure, if we want to insert element at top and delete element from top, then we have to use stack. Stack is a data structure in which we have to insert or delete element from the top position. Stack can be implemented with the help of contiguous memory and array, and non-contiguous memory and a linked list. If we want to implement stack, we can implement by using array as well as linked list. If we want to implement by a contiguous memory allocation, then we have to use array, or if we want to implement a non-contiguous memory allocation, then we have to implement by using linked list. That means a data structure which is show the both property, linear as well as non-linear, that data structure is called linked list. Linked list having a dual property. It can be show the linear as well as non-linear property in the case of implementation. Here the structure of stack, in which we can show if insertion is called here push and deletion is called pop. If we want to insert an element, then we have to push, or if we want to delete element, then we have to pop from top. The deletion is called pop and the insertion is called push. We have to insert only at top position, and deletion is also performed from top position. This one is called bottom element, and this element is we have to assign null for indication of the stack to be empty. Now the next one is queue. This is a next type of data structure which can be also implemented by using array as well as a linked list. In case of queue, a queue is a linear data structure that follow the first in first out principle, which means that the item that is added first to the Q will be first one to be removed. That means the element which is inserted first are removed first, and the element which is inserted last are removed last. That concept is called FIFO, first in, first out. The insertion of an element in a queue is done at one end, and the removal of is done at another end. That means the insertion is take place from rear and deletion is take place from. If we want to insert like this 4, 6, if next element is coming, they inserted here. This position is called rear and this position is called front. If we want to delete an element, then first we have to delete 4, then 6, then etc. If we want to insert an element, then we have to insert from this position. So the insertion take place from one place and deletion can take place from another end. The insertion point is called rear and the deletion point is called front. Here insertion and deletion is called with another name. If we want to insert an element, then the operation is called in queue, and if we want to delete an element, the operation is called DQ. This is a diagram of queue where DQ means deletion of element and in queue means insertion of element. Insertion take place from this position, that is called rear or in queue operation, and deletion take place from this position. This position is called front or DQ at this place. Here this position is also called back, tail or rear position. So in case of queue, we have to fix the position for insertion and deletion so that the data structure is called a queue. Now, types of queue. There are different types of queue: simple queue, circular queue, priority queue. Simple queue is divided into two parts: input restricted queue, output restricted queue. In case of input restricted queue, insertion can take place from one end and deletion is take place from both ends. Output restricted queue, output means deletion is from one end, that is called front, and insertion is from both ends. Same circular queue. If the last node is connected with the first node, then the queue is called circular queue. Here priority queue. Priority queue is divided into two parts: ascending priority queue and descending priority queue. The next one is non-linear data structure. A data structure where data elements are arranged sequentially or linearly are called non-linear data structure. In a non-linear data structure, single level is not involved. That is, multiple level is involved. Therefore, we can't traverse all the elements in a single run only. Non-linear data structure are not easy to implement in comparison to linear data structure. It utilizes computer memory efficiently in a comparison to linear data structure. There is some disadvantage and advantage of linear and non-linear data structure. Linear data structure is in case of linear data structure, there is a wastage of memory, but implementation is easy. But in case of non-linear, the implementation are typical, but it utilizes the maximum memory. That means there is no wastage of memory. Here, now we are going to discuss about types of non-linear data structure. The first one is tree. This is the first type of non-linear data structure. Tree means tree is the collection of nodes in which each node having number of child. This is the hierarchical collection of data. A tree is the hierarchical data structure that consists of node connected by A. Like this. This is a node. This is the child. This is the child. This is the child. And here we have to also create the child of this node. Such type of data structure is called tree. Each node having different child, it may be. But if we want to restrict the number of child, then the tree is converted into different types, which is discussed later. It is used to present hierarchical relationship or structure where each node is The tree can be have 0 or more child nodes but has at most one parent node. That means if a child node, then their parent's nodes is compulsory. Without parent node, a child node does not exist. But parent is individually exist. This is a type of tree in which we have discussed all the basic concepts of the tree. This first node is called root. The connection is called edge. Here the nodes having same parent is called sibling. Here A and B having same parent Q, so A and B is called sibling. The node having no child is called leaf node. This one is leaf node, this one is leaf node, this one is also leaf node. This and this is called leaf node. Okay, if the node having same parent is also called children or sibling. E, F, G are children as well as sibling of each another. This one is called subtree. This one is also called subtree. In the given tree, we have to calculate number of basic points. That means height of a node, depth of a node, degree of a node. Such type of basic points we have to calculate it in the given tree. Height of the tree, that means the number of edges from root node to deepest node is called height of the tree. We can also calculate the height of a particular node. We can also calculate the depth of the particular node. We can also calculate the degree of a node, etc. Here we have discussed about types of a tree. The tree is mainly classified into 5 types: general tree, binary search tree, ABL tree, and MV tree. This is the mainly 5 types of tree which is discussed in the later video. Now the next types of non-linear data structure is graph. Graph is the also collection of vertices and edges, in which vertices represent the value and edges represent the connection between two vertices. This is the all about the basic concepts of data structure. If you any doubts, you can message in a inbox. Thank you.